Greetings, humans, and welcome to a tutorial on the needlessly complicated button. This module is in some ways kind of similar to the classic vanilla. However, as the title says, it's needlessly complicated. So this is what the button looks like. You'll have a button with some color, some text on it, and then three indicators on the top. So what you first want to write down is these three indicators. I'll write this down. 636, 942, 322. Now, the next thing we need to do is we need to figure out which of these indicators, or like what order the indicators go in, these three. So for that, we're going to need to refer to this table here. And this table relies on edge work. So first of all, BOM has more batteries than the number of ports. Let's see. We have 4 batteries, and we have 4 ports, so no. First or last letter of the button label in any indicator label. Do we have an A or a T in any indicator? FRK, so no. Any letter in the serial number is in the button's label. Do we have abort in the serial number? We have a T, so this is the column we're going to use. Now, if you've been paying attention, you notice this table is actually switching around. The rows in this table shuffle, so you kind of have to find what you're looking for pretty quickly. In this case, we're using this column, this one here. I can't actually highlight it. And we're looking for the row that corresponds with the text on the button, abort. So wait for it to shuffle. That one. Okay. Abort, right there. Indicator 1 and 3 is the text. 1 and 3. What that means is the first and third indicator, we need to basically reorder the list to go 1, 3, since that's what we got from this table, and then the remaining 1, 2. So this is the third one, just put that there. So this is the new order of the numbers. Next thing we're going to do is we're going to ignore this Venn diagram, that comes later, and we're going to scroll down to here. Now, for the rest of this one here, 636, will be referred to as the first indicator, 322 is the second, and 942 is called the remaining indicator. Now, we're basically going to follow this table here. First of all, what does the serial end in? It ends in a 6, so that's even. So we're going to go to here. Is indicator 2 odd? Indicator 2 is 322. 322 is not odd, so we go to no. Is indicator 1 even? 636 is even, so we'll follow the yes line along here to there. Is a parallel port present? It is not. We have an RJ, a DVI, an RJ, and an RCA. Parallel present? No. So that takes us to this number here. So 1. I'll write down 1. Now, we need to add the number associated with the button's color, in this case, black. So look at this Venn diagram here. Black corresponds with 1. Add that, and we get 2. Now, this number we get from this table here, and then adding the color, is called the initial output. So now we need to modify the initial output using these 3 rules. For each needy on the BOM, add 4 to the initial output. We have no needies. If indicator 1's digital root is equal to the initial output, XOR indicator's 2 digital root is equal to the initial output, we're going to add something else. So we want to get the digital root of these first 2. 6 plus 3 is 9, plus 6 is 15, so that's a 6. 3 plus 2 is 5. Plus 2 is 7. So our digital roots are 6 and 7. Now, if either of these were equal to this number here, the initial output, we would add the digital root of this indicator. However, notice this does say XOR, so if they're both equal to the number here, the initial output, we would do nothing. In this case, 6 and 7 are not 2. Neither of those are 2. So we're just going to ignore that. If any of the indicators end in the number corresponding to the button's color, not the initial output, the button's color. So in this case, if any of these ended in a 1, none of them do, if they did, we would add double that number to the output. So we would add double the color. So if any of them ended in 1, we'd add 2, since that's double 1. Then once we have that, so in this case none of the rules applied, we have our final number. So now we're going to scroll up to here. We'll scroll up to this Venn diagram, and we're going to figure out which ones apply. Button is red, green, or blue. That's false. Serial contains an even number. Yes, we have multiple even numbers. The remaining indicator is prime. So again, remaining indicator is this third one here. 942, I can already tell that's not prime because it's divisible by 2. And the digital root of the remaining indicator is odd. 9 plus 4 is 13, plus 2 is 15, and then 1 plus 5 is 6. So that is not odd. So in fact, the only thing that applies here is dotted line. Notice that this describes what the lines are as opposed to actually showing you. Solid line is this one here. Dotted line is this one here, the one that has the I inside it by itself. Dashed is this one with the bravo. And then the dot dashed is this one with the delta. In this case, we want dotted, which is going to be India. Now we have that, and we use India in this table here. How long do we hold it? We release it immediately. So there's a couple different options for what can happen. You're always going to hold on this number here, this final number you got. So we're going to hold, quote unquote hold in this case, on a 2. Now you either could get a duration, in which case you would release after that many seconds, or you would get a number, which is the last digit of the timer you want to release on. This is all done by last digit of timer, or you might just keep holding until it solves. In this case, we're going to just tap the button on the last digit is a 2. There we go. Module solves. I'll do one more, but that's basically all there is to this module. Not in factory. Bear with me. Okay, and off we go. Reload this page. One other thing that I forgot to mention is that if your final output here, after all of the rules, is less than 0, if it's negative, or if it's greater than 10, you're going to mod 10. If you're curious, it does say that right here. You would add 10 until it isn't, if it's negative. Anyways, first thing we want to do is we want to, at least when I'm doing this, I don't actually write down the indicators until I figure out what order they're supposed to be in. So does the bomb have more batteries than ports? We have 1, 2, 3 batteries versus 3 ports. They're equal again. First or last letter of the button label in any, do we have an M or an A in any indicator? We do, we have an MSA. So in that case, we're using this second column here. The label is magenta. So find that here. Indicator 2 and 3. So in that case, I'm going to just write down this order. So starting with indicator 2, that's 509. Indicator 3 is 304, and then the remaining is 182. We can now scroll down here. The last digit of the serial number is 4, so that's even. We're going to head over to here. Indicator 2 is odd. 304 is not odd, so we get a no. Indicator 1 is even. 509 is not even, so we're going to follow this there. More A's than D's. We have 2 A's and 1 D's. So yes, we get to -1. Now remember, we add the number associated with the color, so green. So -1 plus 4 is going to be 3. Now we go through these rules. Once again, we don't have any needies, so rule 1 doesn't apply. We need the digital roots of 1 and 2. 5 plus 9 is 14, 1 plus 4 is 5. 3 plus 4 is 7. Neither of those are equal to the initial output. 5 and 7 are not 3. So that doesn't matter. And now, do we have any indicators end in a 4? We do. This 304 ends in a 4, and 4 is the number that corresponds with the button's color. Remember, this is by the color, this last row is by the color, and not by the initial output. Now we're going to add double that number. We're going to add double 8, so add 16 to 3. So that would be 3 to 6 is going to be a 9. I'm just doing mod 10 here. That's not right. I can't do math. Because, sorry, We're adding double, why did I say double 8? We're adding double 4. So that's 8 plus 3, that's going to be a 1. There we go. Yeah, we add double the number associated with the color. So 4 times 2 is 8, plus our initial was 3, so it becomes 1, 11. Anyways, we go over here. Button is red, green, or blue. That is true. Serial contains an even number. Also true. Remaining indicator is prime. Our remaining indicator is 182. Again, that's not prime, divisible by 2. Digital root of the remaining indicator is going to be 1 plus 8 is 9, plus 2 is 11, and then that's going to be 2. So no, that's false. So we want solid and dotted. So this one and this one. That gives us foxtrot. Release on a 1. So we're going to hold on a 1 and release on a 1. And we could just tap there because we wanted us to hold and release on the same digit. And there we go. Module solves. So that's all there is to it. Hope you enjoy this tutorial for a not actually that difficult module that I think people are overly intimidated by. And have a nice day.